Welcome to organic chemistry lesson. Talking about alkanes. Last time we were looking at the alkanes, where we said that the alkanes, these guys are saturated hydrocarbons. We said that alkanes are saturated hydrocarbons. This word here, they are saturated hydrocarbons. Okay, and the general molecular formula is CnH2 n plus 2, where n is equal to 1, 2, 3, 4 up to infinite. So alkanes have a single carbon covalent bonds between carbon atoms. They are called saturated hydrocarbons because they have a required maximum number of hydrogen atoms. They end with the ANE. So these guys, they contain a single bond. That's why they are called saturated hydrocarbons. Then we also talked about the first member to be methane. Meth means one carbon atom. Then as you watch the previous video, then you understand what is going on here. So we now go to preparation of methane. Methane is the first member of the homologous series known as the alkanes. So we now look at the preparation of methane. So methane can be prepared by heating a mixture of anhydrous. Remember, anhydrous is a salt that does not contain water of crystallization. That is anhydrous. Okay, sodium ethanoate. So this is the chemical formula for sodium ethanoate. So this comes from the word of two carbon atoms, 1, 2. So sodium is here, sodium ethanoate, and soda lime, which is called sodium hydroxide. Soda lime called sodium hydroxide, which is an alkali. So when you react anhydrous sodium ethanoate together with sodium hydroxide, you're going to form methane. So this is the equation here. Sodium ethanoate plus sodium hydroxide, what you should find is that, or what you should produce is methane gas and sodium carbonate. When you react sodium ethanoate, so sodium ethanoate will react with sodium hydroxide to form sodium hydroxide. Let me repeat this. We are saying sodium ethanoate will react with sodium hydroxide to form methane and sodium carbonate. Okay, so it is self-balanced. Since here sodium is 2 and here we have 1, 2, so it is balanced. So now let's look at the diagram now, how everything goes about. So we have sodium ethanoate, which is here inside here, plus sodium hydroxide. So you heat the two, then this is the methane gas that will be produced. That is the methane gas that will be produced. Now, when you look at this gas, is collected using downward displacement of water. Why? It is not soluble in water. It is not soluble in what? In water. That's why it is collected using downward displacement of water. So if it was soluble, it would have just remained here. But since it is able to be collected there, it is not soluble in water. Okay, so please, when they ask you to say how do you prepare methane, you tell them that you react sodium ethanoate with sodium hydroxide, where you are going to get methane and sodium carbonate. We now go to physical properties of alkanes. Physical properties of alkanes. So we're going to say that their physical states vary at room temperature and pressure. Remember that room temperature and pressure, it's a temperature that ranges from 20 degrees Celsius to 25 degrees Celsius. So in this range, we are saying that the lower members are gases. The lower members are gases, and others are liquids, while higher members are solids. So what are we saying? These are the lower members. 1, 2. As you move, if they have small number of carbon atoms, those guys will be gases. As the number of carbon atoms are increasing, they are changing from gas to liquid, finally to solids at RTP, where the temperature is 20 degrees to 25 degrees Celsius. Okay, so methane is a gas, ethane is a gas altogether. So as you continue moving down, as the number of carbon chain increases, even the state changes. So we have the 10th one, which is dencane. So that can be known as a solid. So now, so the second reaction, we are saying that the second physical property, their melting and boiling points increases as the carbon chain, which is the relative molecular mass, increases, or if we like that. So their melting point and boiling point increases as the carbon chain increases. So we are saying, are you seeing here? We have one carbon here. Here we have, so the carbon chain is increasing. Look at here. Look at. So the carbon chain is increasing. This is the carbon chain that we're talking about. So meaning we are told that the melting point and boiling point increases as the carbon chain increases. Even so, when you talk about the carbon chain increasing, even the molar mass, which is the relative molecular mass, which is the mixture, also increases. So as the carbon chain increases and the relative molecular mass increases, the boiling point does what? Increases. So using this table, which is here, which one will have high melting and boiling point? The obvious answer is that it is pentane. Why? Because the carbon chain is longer compared to methane, and also the relative molecular mass for methane is lower than the one for pentane. Then we now look at the physical property number 3. Their densities increases as the carbon chain increases. So we are saying that pentane again is more denser. According to the table here, we're going to say that pentane is denser than methane, than ethane, than propane, than butane. Because as long as the carbon chain increases, the density also increases. So these are some of the trick questions that they do ask, multiple choice questions. So please remember that as the carbon chain is increasing, the melting point and boiling point increases, as well as the density. Also, you should know that as the carbon chain is increasing, their states at room temperature and pressure varies. Lower members will have will be gases, then from there liquids, and the higher members will be solids. So those are the three main physical properties of the alkanes. Now let's go to chemical properties of alkanes. When you talk about chemical properties, you are talking about the reactions that are carried out as alkanes react with other substances. So number one is combustion reaction. When you talk about combustion, you're talking about a reaction of a substance with oxygen. Okay, now this combustion reaction, it is in three types. Okay, so we're going to have A, B, and C. Okay, so when you talk about A, in a plentiful supply of air, which we mean as complete combustion. Okay, so alkanes react with oxygen to form carbon dioxide and the water. If they say complete what? Combustion. So when they say complete combustion, the products will always be carbon dioxide and the water. So this is methane, which is an alkane, the first member. So we're going to say methane plus oxygen should give us carbon dioxide plus what? Water. And it is balanced. So these two shows that the hydrogens, there are 4. Even there you can see that there are 4. Then from there you can see that oxygen, because of these two, this is 2 plus these 2, 4. That's why they had put this 2 here. Now I repeat this. When they say complete combustion, there are only 2 things that are formed. It is carbon dioxide and H2O. When there is a complete combustion, then we go to B. In a limited supply of air, which is incomplete combustion. When there is a limited supply of air, alkanes react with oxygen to form carbon monoxide and water. We are saying alkanes react with oxygen to form carbon monoxide and water. So this is the second member of the alkanes. This is going to be called ethane or ethane. Why? Because of the 2 here carbon atoms. So they will react with oxygen to form carbon monoxide and water, and that is the balancing which is there. Okay, so now for limited the supply of air, always remember that what is formed is carbon monoxide and the H2O. Are we together? Then C, in a very limited, they have used the word what? Very. In a very limited supply of air, which is also called the incomplete combustion, but there is a word what? Very. Alkanes react with oxygen to form carbon and the water. Okay, so now this guy, because it has 3 carbon atoms, is going to be called propane, which is the third member of the alkanes. So they react with oxygen to form carbon and water. So then that is the balancing which is there. Okay, so the first chemical reaction, it is combustion, which is categorized in 3, which we have the complete combustion, the incomplete combustion, and also an incomplete combustion but using a very limited supply of air. So for C, when there is a very limited supply of air, what will be formed will be carbon and the H2O. Okay, and this carbon which will be formed is the one which we call soot. We call it soot, and bent carbon. Yes. So that's about that. So now we go to the second reaction. We have what we call substitutional reaction. Substitution reaction. Now we should know what we mean by substitution. It's more or less like we have Zambian team, which is for the females. You know that Barbara Banda is not playing well, and on the bench there is Kundananji. So the best you can do is to remove Barbara Banda and put Kundananji there. That is what we call substitution. Okay, so now a substitutional reaction is a reaction in which one atom or group of atoms in a molecule is replaced by another. A substitutional reaction is a reaction in which one atom or group of atoms in a molecule is replaced by another. Or you can say it's a type of reaction in which the most reactive will displace the least what? Reactive. Now, alkanes undergo substitutional reactions with halogens. Alkanes undergo substitutional reaction with halogens. Now, one will ask to say, now what are halogens? So we're going to say that halogens are group 7. We input this. They are group 7. We use the Roman numerals. So they are group 7 elements. And they are called this name because they are salt formers. Because they are salt formers. So whenever alkanes react with group 7 elements, okay, that is going to be called a substitutional reaction. In the presence of the ultraviolet light, that's a catalyst. In the presence of the ultraviolet, which is the UV. Okay, so we are saying that alkanes undergo substitutional reaction with halogens in the presence of the ultraviolet light. Example, let's look at example here. So halogenation of methane. Halogenation of what? Methane. What we are saying here is that methane is going to react with one of the halogens. So methane can react with the chlorine gas in the presence of sunlight, which is the UV. Remember that the UV comes from the sunlight, to form chloromethane and hydrogen chloride gas. Now, please, let's understand this. We are saying that halogens react with alkanes in the presence of what? Ultraviolet. Okay, so if, let's say for example, you have used methane to react with chlorine, you are going to form chloromethane. So suppose you use the bromine, because bromine is in group what? 7. So it's going to be bromomethane. It's going to be called bromomethane. Suppose you use the fluorine, it's going to be fluoromethane. Okay, so now what we are going to do now is this. So let me just erase this part here. So here we're saying that methane can react with chlorine gas in the presence of sunlight to form chloromethane and hydrogen chloride gas. So this is the methane here. So methane plus chlorine is going to give us chloromethane, okay, plus hydrogen chloride gas. Now let me show you what happens here. This is the mechanism. This is the mechanism. What will happen is this. This is the structure of methane. So when the UV, you know, here there is UV, which is the ultraviolet light, which acts as the catalyst. This guy will come and break the bond between the two chlorine atoms. Then when they break, this chlorine will come and substitute this hydrogen, remove it altogether, and this hydrogen now will move where there was this chlorine. Have you seen the arrangement which is there? We are saying when the UV comes, it will break the bond between these two guys. When it breaks the bond, this chlorine will come and substitute this hydrogen here, and when this hydrogen comes out, it will be replaced by the chlorine, and this hydrogen will go where the chlorine was. That's why here we are saying this is the C, these are the three hydrogens, then the chlorine is here, plus where there was this chlorine, this is where the hydrogen is, this guy here. Okay, so this is the hydrogen chloride gas, and this is the chloromethane. If you want, you can also call it this way. When you have CH3, it is also called methyl. It is also called methyl. So since there is a chloride here, I will just say this is also called methyl chloride. That's a methyl chloride. It is also called methyl chloride. It is also called methyl chloride. It is also called methyl chloride. So now we are saying that this chlorine here is going to be split into two. Remember that chlorine is a diatomic, so it will be split into two. Then one of the chlorine will go and substitute the hydrogen, and when it substitutes that hydrogen is going to go and be where the chlorine that substituted it, that's where it's going to be, and it's going to form hydrogen chloride gas. So in summary about substitutional reaction, we are saying that substitutional reaction is a reaction in which one atom or group of atoms in a molecule is replaced by another. So meaning the catalyst is going to be the what? The UV, which is going to break the bond between chlorine and chlorine, so that one of the chlorine goes and substitutes one of the hydrogen, and that hydrogen is going to combine with the other chlorine which remain to form hydrogen chloride. So during substitutional reaction, alkanes react with the halogens to form haloalkanes. Let me even do this. Alkanes plus halogens, we are going to form a haloalkanes. We are going to form haloalkanes. We are going to form haloalkanes. All together, we are going to form haloalkanes. Okay, so that's about that. So if you use methane, you are going to form chloromethane and hydrogen chloride gas. If you use ethane, you are going to form chloroethane and hydrogen chloride gas. So what are the conditions? The conditions are that temperature is 200 degrees Celsius, then the catalyst is sunlight, which is UV. So here we were looking at the preparation of alkanes, which is methane, where you react sodium ethanoate with sodium hydroxide, then it is going to form methane gas and sodium carbonate. Okay, and the methane is collected using downward displacement of water because it's not soluble in water. Then we also talked about the physical properties of alkanes, where we said that their physical states vary at room temperature and pressure, which we said that the RTP is 20 to 25 degrees Celsius. So lower members are gases, then others are liquids, and the higher members are what? Are solids. Their melting point and boiling point increases as the carbon chain increases. Their densities increases as the carbon chain increases. Then we also looked at the chemical properties of alkanes. We only have two chemical properties of alkanes, which is combustion and substitution reaction. Okay, so substitution, why? Because these guys, they are saturated. All the carbon atoms are intact, so you just need to substitute one hydrogen for them to react. They are very unreactive, these guys. So now under combustion we have there in three categories, which is A, in a plentiful supply of air, where you are going to produce carbon dioxide and water. In a limited supply of air, carbon monoxide and the water. In a very limited supply, you are going to form carbon and water. Then in a substitutional reaction, we are saying alkanes will react with halogens to form haloalkanes. So what are halogens? Are group 7 elements. Why are they called halogens? Because they are salt formers. So alkanes undergo substitution reaction with halogens in the presence of the ultraviolet. So when the ultraviolet comes, it breaks the bond between the two. Then this chlorine will come and substitute the hydrogen, and this hydrogen will go where there was chlorine here, so that they form hydrogen chloride, and this now becomes chloromethane or methyl chloride. What are the conditions? Temperature should be 200 degrees Celsius. Catalyst, sunlight. So the way I also like it when you're dealing with organic chemistry, so that you don't forget about the conditions, you can even do this: CH4, okay, gas, plus Cl2 gas should be able to form CH3Cl plus HCl. This is a gas, and this is also a what? A gas. Okay, when you write this equation, you also put condition number 1 UV, condition number 2 200 degrees Celsius. So that if you write every reaction with their conditions, where on this arrow, which means to form, this reaction, this arrow means to form, you put the conditions, then you're in the right track. That's the way you move. You will not be able to be forgetting these conditions, because chemistry reactions, they like bringing about the conditions. Next time when we meet, we are going to start from isomers of alkanes. Very interesting, isomers of alkanes. So otherwise, enjoy the video. That's where we end here.